Hello everybody. Today I'm going to be walking through Connect 4. I'm not going to do any hard modes or anything kind of beyond the initial scope, but we can talk through, in particular, the Redux stuff and how it's going to tie back into the components. So, main idea is we need a 7x6 grid here, and we need to make it so that when you click on any particular grid column, it drops a tile or whatever into that column. It needs to go all the way to the bottom, unless there's something already in there, and then it needs to stack on top of that. So similar sorted to tic-tac-toe, except instead of being aware of the tile that's being clicked on, the main thing we need to be aware of is the column that's being clicked on. So let's start off. I'm starting from scratch here. I already created and did not open. Created a React app called Connect 4. There we go. With nothing installed. So I am going to install npm install Redux and React Redux, and no router required. Okay, and let's go ahead and kick off a state, or sorry, excuse me, a store. Import create store from Redux. I'm going to create a separate object here as my initial state. I might talk a little bit about that later, but that's just organizationally I want this to be here. Initial state for my store. This is also going to make it really easy if I do want to come back and have like a reset button or start the game over. It's going to be really easy to go back to this state. But that's not essential. What is essential is that I'm going to start setting this up. I'm going to have my reducer function, and then I'm going to have initial. That's how I'll create my store. And then I'll have, a reducer. State action. Okay. So the main thing that's going to be happening in this game, action-wise, is going to be dropping a tile into a particular column. So I'm going to also go ahead and create an actions.js. It's really only going to be one action, at least for now. Drop, I'm going to call them tiles. I feel like there's probably a better name for that, but whatever. And then what I need to know is the column number. It doesn't really matter about the row from the actions perspective. All that really matters is what what column we clicked on. Drop tile. Payload is going to be the column number. Okay, so this will be our action for when someone clicks on a column. This is the thing that's going to happen. And so drop tile is our action. We're not going to totally write this out in our reducer yet, but let's go ahead and set ourselves up so that if action.type equals drop tile, we do a thing. Then at the very end, if we haven't returned, we return state. Okay, so that is our basic setup. I'm going to also add a console log here, dropping onto column action.payload, just to print that out. So next I'm going to take a breather on the data side. And actually, before we do that, let's talk about our initial state. So we need to really have two pieces of data here. One of them is going to be the current player's turn, or whose turn it is right now, which is going to alternate between red and black if we're dealing with standard Connect 4. We can represent that with a Boolean if we want to. And let's actually do that. You could also represent it with a string, so you could do red or black, like that. But in this case, I'm just going to do is red's turn true. Okay, and then if it's not red's turn, then it's black's turn. Cool. So anytime an action occurs, anytime someone drops a tile, it's just going to swap from true to false. And actually, let's go. I have a feeling that's going to be a little confusing to follow. I don't love that. So let's just go with red. And then this can also be black. Okay, and then the other main thing we need is the board. And the board's probably the most confusing part of this whole project. But the board is going to be an entire grid. We need to keep track of a different array for every column is what we want. Because if you think about it, the actions that are going to be occurring here are going to be dropping the tiles into the columns. And so we need to make it really easy to add new things to each column. It's very rare we're going to do anything across rows unless we're looking for like win conditions. We won't have anything to do across rows. So it's going to make sense for us to organize our board as a big set of arrays. Notice that these are arrays inside of arrays. So this first one is going to be column 1, then column 2, and so on. I think we said there were going to be 7 columns, if I'm not mistaken. Okay, so this will be our board. And so once someone drops a red one into this first column, there's going to be red there. And then if black drops one, there's going to be black after that. And then if you get another black, so this is going to indicate kind of if I turn my screen sideways, this would be the one that's closest towards the bottom. And then this black stacks on top, and this black one stacks on top of that. So that's kind of the idea. Okay, but everything's going to start empty. So dropping tiles, you can maybe start to visualize that if someone says they want to drop a tile in column number 2, so 0, 1, oh gosh, let me change this so it'll match my indexes. 3, 4, 5, 6. Yeah, so if someone drops one in column number 2, that means this needs to get a push of either red or black, depending on who the current player is. Let's come back and write that later though. I want to go ahead and start triggering these events first. Okay, so that means we need to create a actual component that we can show on our page. I'm just going to create one here. It would be a good idea if you wanted to create like a grid or a grid column, or there's all kinds of different ways you can organize this. I'm going to keep it fairly simple. And let's make it so that we have a class called gridCell, spins component. We're going to have 2 props coming in. We're going to need an X and Y coordinate. Well, maybe I don't need this. Let's leave that out unless we need it. What this thing's going to look like is we're going to have a div. And inside of that, there's going to be, let's say, this dot props dot x, comma, this dot y. So I'm going to be passing in, when I create these grid cells, I'm going to be passing in a set of coordinates, x and y. That's going to be important so that I can figure out whether the cell should be black, red, or empty. And so y is also going to be the column number, which will be convenient. Okay, last thing while we're on the talk about column numbers, let's make it so when you click this thing, handle click. So I'll create a handle click function who is going to say clicked on column this dot props dot y. If you remember from back in the day, geometry, y is going to be your column and x is going to be your row. Wait, is that true? Am I backwards? X is going to be our column. Heavens. Yeah, x is going to be our column, y is going to be our row in this case. Okay, so I said that backwards. Make sure you have a second to think about that. And we can also test it to make sure that it works. So what I'm going to want is, in order to make a grid here, so back in app.js now, I'm going to need to import grid cell from I'm going to do two nested loops here. So they're going to have a while loop on the outside. And we want 7 by 6, so we want 7 columns, 6 tall. Y plus plus, fool me once. Let x equal 0, x less than 7, x plus plus. Now cells, we're just going to push a new grid cell where x equals x and y equals y. And then down here, we will render cells. Like that. Grid cell action. Oh, this dot handle click. Oops. Cool. So that does not look like a grid, but we do have coordinates. Let's make it also, one thing that's going to make styling a little bit easier here is if we actually put all the grid cells that are part of the same row. So x equals 1, x equals 2, x equals 3. I'm going to put all those inside of a row. Let me think for a second. So we want all of these grid cells enclosed in a div. Oh, yeah, okay, I'm with you now. Actually, maybe I'm not with you now. So what I want to do is enclose all of each row into a container, and that's going to be for styling purposes. So this grid cell, this inner loop is all going to form one row. Okay, row equals this. Row two, 3, 4, 5, 6, 7. All right, cool, that worked. All right, so what I'm doing is I want to make this row be in a container of its own. So I'm going to go ahead and just stick all of the cells for one row together into a single array. And then I'm going to push them into cells with the div wrapped around them. So basically I get an entire row with the div wrapped around it. Here I'm also going to be able to do class name equals row, which will be helpful for styling. And then within grid cell, I want to give all grid cells a class name. Oops. I guess just cell is probably going to be fine, at least for now. Okay, so this still does not look any grittier than it did before, but that's because we need to change our cells to be in line with each other. And why don't we go ahead and do that, actually. So let's make it so that every cell, first of all, has a border, solid black. Now we want every cell to be display inline block, padding 25 pixels. Font family, something monospace. This will hopefully put a little less variance in between the shape of everything. Yeah. So monospace just because every number is a little bit wider if you're not using a monospace font. Monospace meaning everything is the same width. So that gives us what's starting to look like a board, I guess. And our coordinates are fine. They're, I guess, kind of upside down by normal standards. So I would expect 0, 1 to be down here, 0, 5 to be up here. So we can actually fix that real quick. Instead of starting our y at 0, which we are, we actually want to push them in the rows in the opposite order, right? So we want this row to actually be the first row, meaning the one up here at the top, and then this row that's currently at the top to be the one that's on the bottom. That's just at least how my brain sees this thing from like a coordinates perspective. This one being 0, 0 makes the most sense, meaning it has to be the last row that we push into the set. So that means instead of starting at 0 and going to 6, we need to start at 6 and go to 0. Actually, I guess we need to start at 5 and go to 0. Come on, come on. I bet I dropped an infinite loop in there. Oh yeah, plus plus. That's not really going to end. So minus minus, because I'm going 5 down to 0. It's pretty important you actually move in the right direction. And that'll keep trying its best for a little while. So while that's booting back up, here's how my code, well, here's how my code looks now. Starting at 5, going down. Here we're starting at 0, going up. And again, the only reason we're making this change is so that the rows ordering is going to be flipped. And so now you can see we've got 0, 0 down in the bottom left, and then we increase, as you would expect, with x values. And then the y values also increase up in this direction. Basically just mirrored everything. Cool. All right, so we got our grid. Everything looks very Connect4-y. Now let's pull up console. First of all, we are iterating in order to create a set of components, so we need to add a key. And so our key for the div is going to just be the y value. And the key here is going to be what would our key be here? I guess we could do like an XY combo of some kind. How would you actually write that though? See if that works. Huh. Oh yeah, that makes sense. That's cool. X plus, it's not X plus Y, it's X plus Y. When this works, I'll pause on it for a second. And then one more right there. Good, come around, come around, come around. Okay. No useless concat, that's pretty awesome. Okay, let's do this for now. Luke, figure out a better way to join these keys. What we need is some kind of unique identifier for each grid cell though. Actually, wait a second. Let me just try X. Hey, sweet. Okay, overthought that one by a lot. So within this for loop right here, uh, we need a unique key, which is going to be x, because each iteration is going to have its own x. Then out here, as a separate iteration issue, each one of these is going to need its own y, or excuse me, its own unique key, which y makes sense for out here. So I think that should be just fine. React's not complaining about it. Again, this one's getting us past this iteration, this key is, and this key is getting us past this outer iteration. So things look okay, and you can see that my column clicking is working, so I can click anywhere up column 0, and I'm getting the column 0, or over here on number 6. So I'm actually getting notified about the right column that I click on, which is pretty cool. It's going to be useful. Let's actually work on that usefulness now. So we've got, now we're pretty much done with app, now that we've got this set of for loops going over here to generate the grid itself. App itself shouldn't really have a whole lot more business to do. I do want to, just because I'm weird, I want to go ahead and add cursor pointer so that it looks like these things are clickable. There we go, now we're talking. Just change the mouse a little bit. Okay, and I've got my action here called drop tile. I need to pass in the column that is being dropped into. And we already know the column that's being dropped into within a cell. We're printing it out right here. And handle click is also where we're going to want to fire off props.send tile drop. Let's call it. My input is going to be the column. So this doesn't exist yet. I'm going to create this in just a second. But we know that in order for this to work, we need to pass in the column that is being clicked on. Oh, that's not actually right. Let's see. I need to bring in connect. That's what I need. React Redux. And now I'm actually going to use my map to state and dispatch. Excuse me. State to props. And here I'm going to do dispatch to props with grid cell. So ES6 notation here. Okay, so state-wise, I actually don't actually, I am going to need something soon. I'm going to need to know whether the tile that I'm on is actually, like I'm going to need to style each tile. But for now, I'm going to leave this empty, so I'm not going to return any data through. For dispatch though, this is where I'm going to need to send tile drop column, and that will be dispatch, and I'm going to have an action, which will be my drop tile action. Cool. I can ES6 this as well. There we go. So still function, send drop tile, you pass in a column, and then it's going to call dispatch with the drop tile action with the column set as the payload. Just to quickly look back at, oh, that's awesome. Look back at drop tile, you can, or drop tile, excuse me, you can see at the top here, That's what my function looks like. All right, so I should actually now see things happening in my store. So dropping on to call, that text should actually be printing out now. Oh yeah, gotta do the provider. You know, I thought to myself I was gonna forget this. I said, Luke, you're gonna forget this. And then I continued to do it anyway. I'm just wiring this up from the very beginning. Oh. All right, cool. So I got my provider wrapped. That should make it so that I can actually connect, and I can do this, and you can see that data is flowing correctly. I get one message from my actual component, which is the clicked on thing here. Then I get another message from Redux announcing that it received the action. And so my action now needs to do something. And in particular, I want it to start styling these things. But first, we're just going to change it in the store. Okay, so if someone says they want to drop a tile into column number 1, for example, the tile that's going to get dropped is going to be state.current. This is the person whose turn it is right now. It's either going to be red or black. And so state.current, if someone clicks, whoever is the current player, that's the color of tile that's going in. The array that it's going into is based on action.payload. So 0 is going to be coming through if it was the first column, 1 if it's the second column, and so on. So we can actually use this thing as an index right here. So the row that we're dropping into, and remember we need to keep immutability in mind here, which makes things get a little bit weird, but we need to concatenate whatever is there already with a new tile, right? So state.board, hang with me here, pause it if you need to, state.board action.payload is going to be used as our index. So this is going to give us one of our rows back, and then we want to concat that with the tile. So this is going to be our new row. So this is going to, and by row I mean column. That's confusing. Let me change this to column. This whole flipping the screen sideways thing isn't working out. So we've got column. This is our new column. Remembering each one of these is a column here. So this is our new column with the new tile concatenated on there. Now what we need to do is we need to keep everything else the same, but we need to update just the one that just got changed. So that means we need to make a copy of the board, state.board.slice, need to copy, can't change directly. Immutability. So we can't change the board directly. We have a copy of the board, slice with no parameters is going to just copy the array. But then we also need to say board action.payload is equal to call. And this is the last part. We don't want an actual copy of the board. We want a copy of the board with the new column inserted. Need to update column with new tile. So we had one column that had a new tile. We pushed it in or concatenated it in right here. This is where we actually swap this column back into the board. So make the column, make a copy of the board, combine the column and the board together. I'm feeling that's probably, this code right here is probably the most confusing part of the entire project if I had to guess. This is where immutability gets a little bit weird too. With arrays inside of arrays, there's a lot to think about. So happy to talk about that more in person if you want. We do need to remember that current is going to become whatever it is not right now. So I'm going to use a ternary and say if it's currently red, then it should become black. And if it's currently not red, then it should become red. So if the current player is red, then make the current player black. Otherwise, that means the current player is black, therefore make the current player red. And then board is going to be this new board right here. Cool. All right, that should not give us errors, but unfortunately we can't really test that too easily yet. We need some kind of like implication of this. So I'm going to start off trying to style stuff a little bit. Let's see. So I'll come back and look at this in a second. This is, again, the core logic for the whole game. Mostly finished, actually. But I do want to have a cell player 1 style and a cell player 2 style. And for now, I'm just going to say player 1 is black, background color black, meaning let's make the font color white just so it's a little more visible. And then for this one, we'll have the background color be red, and we'll keep black text. Cool, so we got a P1 meaning player 1 and P2 player 2. We could also just call that red and black. Now over in our grid cell, it's a responsibility of each cell to figure out what colors its background should be. So everything's going to have a cell class. It also may have a P1 or a P2 class, and that's what we need to give it some logic to figure out. And so the way we're going to know, or the way each cell is going to know, is based on comparing the board that exists over in the store. Let's open both of these real quick. Comparing the board here with each individual cell's coordinates. And so what we want to know is, looking inside of the board, we're going to use the x coordinate to get to the right column, and then within that column we're going to look for the right row. Gosh, this inversion's kind of messing with my head a little bit. Okay, so if this dot props, and this is going to be a little bit code English here for a second. So if the to the board, this dot props dot board. I'm just going to alias some of my variables real quick. X equals this dot props dot x, and const dot y equals this dot props dot y. There we go. Okay, so if the board's x value and y, if the thing at x, y is not equal, to undefined. So all these right now are undefined. If it is undefined, then it needs to just be white, or the default whatever color here. If it's not undefined, then that means it's either going to be red or black. So if board xy equal to red, P1 was black actually, so this would be P2. There we go. So classes is going to start off as the string cell. If it is the case that it's defined, and it's defined as red, it's going to be cell concatenated with P2. Otherwise, it's going to be cell concatenated with P1. And we're going to use that string, as the actual set of class names here. So hopefully that makes sense. Let's make sure this works before we study it too hard. Whoa. Good thing. Oh yeah, right. This dot props dot board. This is the board coming from our store here. So that means we need to actually get it out of our store, which we do with state to props. So we're going to get out the board and just call it board again over here. I think that should fix our problem. Hey, cool. So this should be a black and a red and a black and a red and a black and a red, black, red, Actually pretty awesome to look at. Cool, so again, the main logic here is we've got all these arrays. There's three possibilities. It could be undefined, meaning that there is no tile. It could be red, meaning it should have the player 2 class, or it could be black and have the player 1 class. The nice thing about this distinction is all the styling is being done basically right here. I mean, there are the CSS things, but here determining how a cell looks is all happening in this bit of code. The information, so if we wanted to do something like hard mode, which is figure out when one player has won, that all of that's going to be able to happen over here in the store, because this is where we have the raw information without worrying about, you know, the fact that some are red and some are black, or maybe there's a third player where some are green, and you know, you don't have to worry necessarily about all that detail in terms of appearance or view. If we focus on just the model, all the game logic can kind of thrive off of this data. So this is a really good example. If we were to take it further and spend more time on it, it would really benefit us of having a separation between the view and the model here. Okay, so this is our grid cell. Again, this is all just aliasing stuff. Here we're doing the styling, figuring out whether the current cell that we're at is supposed to be red or black, or neither. And then no real complexity when it comes to the cell. We do have to handle one action, one click event, I should say. And all that's going to do is dispatch an actual action to the state, which has drop a tile in whatever column I'm a part of. So again, over here in our Redux store, the action is called drop tile. And what drop tile does is, it's a little bit weird, but it's going to grab the column that was clicked on. It's going to concatenate in whoever the current player is, either red or black. It's going to concatenate that string into the column and give us a new column, the old thing plus whatever the newly dropped tile was. Once we get that, we need to update the board. So we can't just modify the board because that would violate immutability. And so we need to do slice, which is going to give us a copy of the board. And a plain copy of the board is not interesting because it is the same board. So we need to take the copy and update one little piece of it, board being the copy. So I'm able to update, what I would not want to do is state.board here. That is updating the old board. But board is coming to life right here. This is where it's born. And it is something that we can change. So here I'm modifying board and making it part of the new state. So that's all okay. And I would recommend, if this seems dense, I would recommend maybe pausing and taking a closer look. Cool. Beyond that, I don't think there's a whole lot to it. We did have those for loops back in app.js. I'll pause on those for a second. Not really going to talk about them a whole lot. X is for the x-axis, Y is for the y-axis. There's a little bit of talk of keys, but honestly it's not that interesting. But let me know if you want to talk more. And yeah, I think that's pretty much it. So it looks like it's working. We could also do something. One thing I'm not doing is capping it here. So you could keep clicking and dropping tiles. I'm just clicking a bunch right now. Nothing breaks, but we're storing more information than we need to have. We probably could have an if statement or something back there that's like, yeah, well, you can only go up to 6 tall. And if it's more than 6, then chill out and maybe don't, alternate the player. Let that person pick again or something. But it's kind of in the weeds, a little beyond the scope of the exercise. Hopefully that was helpful, and let me know if you have any questions.